All right, so an example, we're going to draw it our normal distribution, but with a mean of 52. So let's write how that distribution is. X is normally distributed, normal distribution. X is normally distributed. Remember our X with our squiggle, we should be practicing that. With a mean of 52, the mean goes first, and a standard deviation of 11. That's our mean. That's our standard deviation. 52 and 11. So if I was looking at these values, I'll just draw a little normal curve real quick over here on the side. It doesn't need to be perfect. The mean's in the middle, that's 52. We have 1, 2, 3 to the right, 1, 2, 3 to the left. All right, we're adding standard deviations to the right. So 52 plus 11 is 63. 63 plus another 11 is 74, and 74 plus 11 is 85. Now in the other direction, we subtract our standard deviation. So again, the mean's in the middle, that's 52. Now we're going to minus 11, minus 11, minus 11, because that was my standard deviation. So 52 minus 11 is 41. Minus 11 is 30. Minus 11 is 19. All right, so for this first problem, let's continue to practice writing our probability question mathematically. It says, what is the probability that a randomly selected student would have scored between 41 and 63? The probability, that's that P, of a student scoring between 41 and 63. Remember, when you have between, the random variable X goes between 41 and 63, and our signs are progressively getting bigger. 41 is the smallest, X is bigger than 41, 63 is bigger than X. Those inequalities will always be facing the same way on that between situation. All right, when I'm looking at my between, let's highlight just to start practicing that too, okay? I drew my picture. We are going between 41 and 63, and we're looking for this area under the curve. That is the corresponding probability between 41 and 63. Well, we can see with our empirical, that is 1 standard deviation to the left of the mean to 1 to the right. So that is a 0.68 or a 68%. You are going to be required to write your question mathematically as well as your result. All right, so make sure you are practicing that even when we're using the online calculators, which we will get to at the end of this chapter. Make sure you are practicing this. All right, with the empirical rule, there are certain probabilities that we can approximate without an online calculator. So you need to make sure you're practicing that too, because obviously with an exam, if we don't have access to the computers, then we're going to need to be able to do the ones by hand. I will always give you problems that you can approximate by hand if I'm asking you to approximate it. All right, the probability a randomly selected student would have scored between a 30 and a 74. Again, probability of X being between 30 and 74. So 30 is the smallest, less than or equal to X, less than or equal to 74. All right, progressively getting bigger. If I sketch this, we are 2 standard deviations. This is the mean, 1, 2 to the right, 1, 2 to the left. And we are looking at the region between 2 to the right to 2 to the left. All right, that is equal to 0.95 or 95%. And finally, if I'm looking at the probability that a randomly selected student scored between 19 and 85, well, that shading wise is between 19 to 85. It's almost our entire normal curve. Remember, the normal curve does keep going on those tails on each side, but they're so small that that's almost nothing. All right, the probability that we are 1, 2, 3 to the right of the mean 1, 2, 3 to the left of the mean is equal to 0.997. Almost 1, but not quite there.